not this.
Okay.
That'll be like a part of it.
If I unplug it and plug it back
You
in.
should have plenty of time. If you have any questions, there's 5 options.
What time is it?
They're all on the B courses. So once you're on the B courses, you should be
That's it.
okay.
Thank you so much.
No problem. Still warming up.
Oh, I don't know if this is. Oh, it is. Okay.
I could try the old direct.
Yay.
All I'm saying, I'm a tech whiz. Does this also have an Ethernet? All right, that should be fine, I think. Hopefully the internet connection is stable. Just, I guess you're recording, screen sharing. Oh, okay, it's past time. All right, good. I think you're good to go. Just make sure to talk pretty loudly so we can hear you, and stay close to it. All right.
Okay. Hi, everyone. Today, Megan and I are going to be teaching this lecture. So, yeah. Welcome to week 4, Monday. Some announcements. Second homework is due on Wednesday. As for office hours, thanks for those of you who have been showing up. If you need any help with like the homework, or you have any questions about anything we've gone over in lecture, please come. I know like turnout really fluctuates. Like at my office hours, no one was there, which is fine. But like come say hi, or like we can work on stuff. If not, then I just kind of sit there. So come. So a quick recap from what we went over last week. Maybe just talk about this with the people around you. What is recursion, and then what's the difference between dictionaries and lists? So I'll give you like a minute or two to discuss with the people around you. Totally lost all the controls. It's fine.
I'll explain it to you.
I feel like that would fix that. Okay, awesome. So does anyone have any ideas on what is recursion? Anyone want to share? Yes.
Recursion is when you call a function within the function itself.
Yeah, exactly. Yeah, so we did those demos, the demos last time about like the Fibonacci numbers and stuff like that, about like calling a function within itself and having to take that like recursive leap in faith. So kind of confusing to think about, but can be really helpful in some cases. How about how dictionaries are different from lists? Anyone have any ideas on that they want to share? It's okay if not. Yeah, so dictionaries are like with those like curly brackets, and they have like keys as well as like values. So lists, it's like only one element, whereas like you can like reference stuff in dictionaries with like a string or like whatever you set to be the keys in your dictionary. Yeah, so they're both pretty useful. So just a quick review. Yeah, so now we're gonna kind of transition to new material. So we're gonna be talking about NumPy today, which is a really, really important and cool package in Python. So a way to make our code more powerful, just generally, is import statements. So, you know, different packages like math or random or NumPy, like I just mentioned. The reason we import packages and different libraries and stuff like that is so you don't have to like write all your own functions, right? Like stuff like this have ways of generating random numbers or like calculating the standard deviation. So you don't have to like, you know, reinvent the wheel and like develop a function to do all these things. You can just do like import whatever package or library you want, and then it'll come like preloaded with all those different functions within that package. So kind of what that looks like is you'll do import the package name, and then kind of like an optional part of this import statement is as and then alias or whatever you want to call it. So yeah, for example, we're going to talk about NumPy today. So typically this is what this looks like. We do import NumPy as NP. So it's kind of just like the shorthand way that you want to call it in your code. So people typically use NP just because it's like short. I don't know. But you could call it whatever you want in theory. Yeah, and generally these import statements are put at the very beginning of your code, because like if you import stuff later on in your code, then you wouldn't be able to use it before. So it's just kind of good practice to put all your import statements at the very, very beginning. So a really cool part about NumPy is NumPy arrays. So last week and times before, we were talking about lists, right? You know, we have those square brackets and we have like all those numbers or strings or whatever we want in our string, in our list. Yeah, so it can be numbers, it can be whatever. But in NumPy, it's a little bit different. They're called arrays, and you can start them like this. So array equals np.array, and then these like soft brackets, and then the hard brackets, the square brackets inside, like as you would call a list. And it has the same indexing rules as lists. So, you know, if you did ARR brackets 1, it would give you the second element. The same way for lists. So why would we care if it's like the same? Why would we use this NumPy array thing? But they're actually really, really cool. So just as kind of a review, let's say we have these two lists, list 1 and list 2. They're defined the same way. If we did 3 times list 1, what would we get? What would be the output? Any ideas? 3 times list 1. Yes. Yeah, so that would be ideal. We would hope that would happen, but actually lists are kind of annoying, and it would be this. You would literally get 3 times your list. Like it would just stack on top of each other at the end, which isn't super useful in a lot of cases. The other part to this is, what if we did list 1 plus list 2? Based on what I just showed you and a list being annoying, does anyone have any ideas what this could be? Yeah. Yeah, exactly. So it would just like add them together, not element by element, but just kind of like tack them onto each other, which isn't super helpful for most of the time. But that's why NumPy arrays are awesome. Because if we did the exact same thing with NumPy arrays, we would get, you know, what we would kind of want in most cases, right? So if we're multiplying 3 times an array, it would multiply each element in the array by 3. And then if we added 2 arrays together, it would go element by element and add those 2 values. Something important to notice about arrays, especially for this last example here, is to make sure the arrays are the same. Oops. To make sure two arrays are the same size. Otherwise, you're going to get an error and it's not going to work. But yeah, this is kind of why NumPy arrays are really, really cool. Some other cool things that you can do. NumPy has really cool functions that calculate like the mean. So instead of having to like sum over your list and then divide by the length of your list, you can just do np.mean of your array and it'll give you the mean. They also have functions for calculating standard deviation, STD, and also percentile, as well as median. NumPy has like so many different things. You can just look at the documentation, which we'll talk about a little bit later, but it has a lot of really, really powerful functions inside of it. So kind of building off NumPy arrays is 2D NumPy arrays. And these are kind of tricky to think about, but basically it's kind of like two-dimensional arrays. So instead of just like one long array, this kind of has like two within it. So you can kind of think of it of like as like a matrix a little bit. So like, for example, if you wanted to contain like X and Y coordinates, maybe like the 2D array would be a good format for you. So a lot of like image like data and stuff could be stored in these 2D NumPy arrays. And the really tricky part about 2D NumPy arrays is indexing and slicing. And yeah, it's definitely okay if you don't get this right away at first, because this still always confuses me. But kind of how it works is, at least for 2D arrays, you kind of have these two axes. So the 0 axis is like the rows, and the 1 axis is the columns. And of course, we can have more than 2 axes, but just as a simple example, we only have 2. So this is kind of how you would think about, you know, like pulling out certain parts of this example matrix. So this first example here, you know, we're using these square brackets again, but instead of just putting one number inside these square brackets, we're putting 2 separated by a comma, right? Because we have a 2D array. So here, this 1, this is telling us to look in the first row, right? The first 0 axis. So that would be this orange square right here, right? Because Python starts at 0, so this would technically be the second row. And then it's also telling us to look at the second column, or the 2 column, which would be the last column in this case. So with those 2 like parameters inputted, we know that it's going to give us this 3 value right here. Another important thing to know about arrays is this colon thing, which basically tells us to give us everything within a certain axis. So in this case, here we have colon, and it's in the 0 position. So it's going to give us everything in the rows column. And then it's telling us 2, so the very last column. So this will give us the last column in this array. So all of the rows, only the last column. And some other kind of tricky notation is if we use this colon, but we also put a number, whether it's at the end or the beginning of the colon. So in this case, it's saying all of the elements up to the last element. So this -1, what that means is it means the very last element. But when you're indexing like this, it's not including the last value. So in this case, it would only give us the first, or here, because it's in the rows column. So it would only give us the first 2 rows and exclude the last row. And then it's telling us the very last column. So then this would give us these 2 3s here. I know that's really confusing, so please ask questions if you have any, or if you want me to go over it again. Yes. Yes, that's a good point. Maybe I made a typo. Let's see. Yeah, so here we're going from all of the rows up to the last one. And then it's the 0th. So yeah, I think I meant to have a 2 there. If I'm looking at that right. Yeah, I think it's supposed to be a 2. Good point. See, I make mistakes with this all the time. It's really confusing. But it's really something you just kind of play around with. You know, the chances of it working the first time, it's like, you know, it's hard. Like, this stuff is hard. Cool. Yeah, there's also like axis-wise operations. So you can like calculate the mean or the median along a certain axis. That's just kind of how these NumPy mean and median functions are defined. So in this case, if we have our array and we want to calculate with respect to columns, we can put in axis equals 0, and it'll give us the mean along every column. We could also put in axis equal 1, and that will give us the, you know, the mean along every column. So just some cool things that NumPy can do with different NumPy functions. Yeah, and if you forget how something works, or, you know, like I did, I just made a mistake, you know, maybe I would like Google, like, how does array slicing work? I know that I do this all the time. Us instructors and interns, we do this all the time. If you don't remember how something works, literally just Google it. There's like tons and tons of things online. So I've linked the NumPy documentation here. Yeah, I like forget like tiny dumb things all the time. But it's fine. Like, that's what the internet's for. And NumPy can do tons of cool things. So I encourage you to just go ahead and explore it. It has really, really cool and powerful functions in it. So now I think it would be useful for you all to get a chance to kind of explore NumPy and NumPy arrays. So I've included all the different Decal staff heights in inches. And then a couple problems for you to go over in a Jupyter notebook. So I encourage you all, if you're able to, open up a Jupyter notebook, import NumPy, as I showed you, and then try and tackle these questions. And if you run into any issues, us instructors will be around and we can help you out. If you don't have a way to open up a Jupyter notebook or something right now, maybe work with the people around you. But yeah, I'll give you a couple minutes to see how far you can get with these questions. Does anyone need to still sign the attendance?
Yeah, hold on.
So hopefully people were at least able to like try most of these questions. I kind of just want to go over some ways to approach this. So wait, let's see. Wait, Megan, how do you get to? Where's the is there a Jupyter Notebook app? Oh, nice. Cool. Cool. Yeah, so I'll just go over quickly like some of the ways you could have approached this. So here it's, making an array of the heights. So I'm just gonna copy and paste this just to save time. I saw a lot of you, sorry, Windows computer. I saw a lot of you making like two separate arrays, which the question wasn't super clear. But you can also just make one array of all of the staff heights in order to solve these problems. So here we can do heights equals np.array, the soft like parentheses, and then the hard brackets. Oh yeah, good point. And you want to import NumPy first. That's important. import numpy as NP. So we've made our array of heights. Now, if we want to calculate the mean, right, numpy has a really great function, np.mean of heights. And this will give us the mean heights of the staff. So pretty cool. You don't have to like write your own mean function. The second part, say all the interns had a growth spurt. We want to add 1 inch to all the interns' heights. A way to go about this is like indexing this array. So we can do heights, and I put the interns' heights at the very end of this array. So let's see, that's the 0, 1, 2, 3, 4, 5. So the 5th element to the end, we're going to add 1. And then we can call heights. Oops. Oh, I typed in the wrong thing. And then we add 1 to the last 3 elements. So that's just a way of indexed slicing. I guess I'll zoom in some. Sorry, it's small. And then the very last part, sort the heights from shortest to tallest. This one's like kind of a tricky one because I didn't really tell you. I just wanted you to practice Googling things and exploring NumPy. So NumPy has this really great function that's np.sort that literally just sorts it for you. So we could do heights or np.sort heights. And it does it for you, which is really cool and really helpful. Yeah, does anyone have any questions about this? Cool. And now I'll pass it off to Megan.
Okay, so now we're going to talk about some extra material in regards to NumPy. So there are a lot of statistics functions NumPy has, so you can do order statistics and averages and variances. So for example, we have the NumPy.max and the NumPy.min functions, and these only work for 1D arrays or lists. So these output the max value or the min value for the array or the list. For arrays that are 2D or greater, you can use numpy.amin and numpy.amax, which outputs the min and max along a specified axis. So this is an example, and I'll go back to the Jupyter notebook. So I imported numpy as np, and then I made a different array just because it seems a little bit more clearer. So if I run np.amin of a, it should give the largest value in the entire array. So if I run that, the smallest number. So if we run that, we get 1. But if we run this, which is np.amax of a along the axis 0, it should return the largest, it should return an array of the largest value in each column. What did I do? So in this first column, the largest value is 2. And in the second column, the largest value is 4. And the same thing should happen for this last one. But this is the smallest value in each row. So these are how you use those 2 functions. And yeah, you can do them for the minimum and the maximum. So NumPy also has a bunch of different other functions like median, mean, standard deviation, variance, which we also talked about before, and you should probably have to use these in the homework as well. So now we're going to talk about errors and debugging. So there are some common types of errors such as overflow, type, index, name, file not found. So the first one, overflow error, means that the output is too large. So for example, we have 5.2 to the 1000th power. And if you run this in Python, it gives you an overflow error, meaning that the result is too large. Oops. There's also the type error, and it basically means that an operation was applied to an object it doesn't work with. So for example, if you pass a list into a function when it expects like an integer or something else. An example of this is I wrote this function square, which takes a number and multiplies it by that. But if I input a string into it, it'll give you a type error because you can't multiply a string. The third most common one is index error. Pretty much your indexing is out of range. So for this example, hello, and your index is 10, it's going to tell you there's an error because there aren't 10 elements in hello. So if you go back here, string index out of range. The name error is basically means if you have a variable that's not defined. So if I just ran x plus 2 without giving a value to x, it'll say x is not defined pretty much. Yeah, name x is not defined. And the last one, file not found error, it pretty much means that whatever file you try to open, you probably didn't download it to the right path or it's not downloaded at all. So I just put keyboard smash some letters that I obviously don't have a file for and no such directory. So this is pretty useful. This should come up in one of the later homeworks where you have to open files. So if you get something like this, it probably means that you haven't downloaded it properly or you haven't downloaded it at all. So yes.
What is the directory that this is calling?
It's usually wherever your Jupyter notebook is.
You can access anything that's within the same subfolder or folder or etc. Basically, like within that where you launch your notebook. You launch it up. You can use it directly.
So basically, errors are pretty annoying, but if you know how to read them, it makes debugging so much easier. So these common ones, like especially this one, the name error, if you forget to define a variable, it'll just tell you, which is pretty nice for Python.
Writing a lot of code and you're getting errors, I'll always go back to the traceback. As you saw in the examples over there, it'll show you sort of where or what line caused that error. And so sometimes you'll, in some cases, you'll get like a giant wall of error messages and whatnot, and it'll be kind of daunting. But just follow it back to traceback and sort of like, if necessary, step through bit by bit. Good debugging method is sometimes like if you find a line that your error is occurring on, right, based on the traceback, that message, then put like a print statement there or comment it out or whatever, depending on obviously like what kind of problem it is. But say if you notice that like you're getting a string index out of range and you're doing it within a loop or you're trying to iterate or something, and you're like, oh damn, how did this happen? Well, maybe you're like where you're trying to start or end your iteration is at a value that like doesn't exist, right? So maybe try printing like what you're trying to iterate through or something like that. It's like just print that out to the notebook or something. In general, it's just like a good little tip to remember.
Also, if you ever see an error you're not sure about, I linked a documentation for errors, and it pretty much shows like all the different types of errors you can encounter. So you can just open this. So there are a bunch of different errors, all of these. I haven't seen all of them before, but I've seen a lot. So if you ever, like, I don't know what this means, just open this documentation, like search for it, and you should be able to find it. You want to give an example? You want to give an example?
I mean, in general, like when it comes to debugging and stuff like that, like honestly, most of it will just come from you code a lot, you start figuring out like patterns and things, and so it's kind of impossible to go over like every single scenario where things might be going wrong. But there are some like common cases that you can be aware of. So like I mentioned before, sometimes if you're iterating, you have like a for loop, right? Or a while loop. You're trying to iterate through a bunch of stuff. And you notice that like, oh crap, I'm getting an error. Or even if it's like not an error, you notice that the output of whatever you're doing doesn't seem to operate on like everything in this list or everything you're trying to iterate through, right? So if you're seeing like that situation, for example, you would think like, okay, so there's something going on with my bounds, right? My like stop condition for this iteration. And then you can debug by, putting a couple print statements in there, printing what values are at different points, see if you're running through everything. And that's like a good strategy to help you step towards your problem. You can also, in general, when you're coding, if you have a huge chunk of code and there's some kind of bug in there, it can be really, really frustrating to debug. So a lot of time it'll come down to how you break apart your code as well. So for example, if you have like, if you notice, say that you're doing a lot of, operations and you notice there's some errors popping up within there, maybe it's a good idea to break that into smaller expressions instead of one giant blob, where it might be harder to like track back something, right? Keep in mind that the tracebacks, they give you the line number. So if there's like a shit ton going on in that line, then debugging is going to suck. I mean, it's just a lot of like things where, yeah, you're going to encounter some bugs, but the more you code, the more experience you'll get on how to avoid them, or at least like how to make your life much easier when debugging. Last one quick thing I didn't notice some people ask was sometimes when you do operations with doubles and stuff, you get at the end like, oh, it's like 5.0 plus 2.0 is 7.000002 or whatever. Like the only reason I'm saying this is some people ask about it. That's like kind of just how Python and other programming languages work when you're doing operations with doubles. You sometimes get floating point errors. That stuff is like annoying, but it doesn't mean that your math is wrong or anything. It's just a sort of artifact of how data is stored. So if that's the case and you notice that like your expressions aren't, working out or whatever, you can account for that either by checking quality a different way, or if it's really bad, adding like I think you can probably check like the error between what you expect and something else, absolutely got another. I don't think that comes up often in Python. I don't think that kind of thing comes up a lot in Python. I've definitely had issues with it in other languages, but just like some things some small things to be mindful of. Shouldn't be a big deal. Honestly, if something comes up, Google it.
Like someone asks a question about code, I literally just like off the side Googling it. So yeah, just Google it.
Small word of warning though is that like obviously sometimes you'll be like, how does this thing work? And you'll copy paste an example from a website or Stack Exchange or whatever. Or like everyone does that, obviously. But always remember if you are copying stuff, like you should know exactly what the context of it is. Like just a common pitfall of people trying out like new examples or whatever, and they're like, oh my god, this broke everything. Just heads up.
The error that gives you for like the answer is too large. How can you work with that? For example, like in astronomy, you have orders of magnitude for luminosity or mass or whatever. So how do you actually work with data if you cannot show it?
Yeah, so I mean, this was like, I don't know, 5 to the power like 1,000, right? So, I mean, that's a pretty big number. I feel like if you're working with like real life values, you're not really gonna run into this. But I mean, maybe if you do like change, like I guess that's my advice to like
96 or however you want to write it.
Yeah.
Yeah,
Science
that's meant
conditions,
for.
so, yeah.
Then you can store it as just an operation and calculate out like 16 quintillion or whatever.
Exactly. Yeah. Any other questions about errors or NumPy arrays? Well, that's all we have for you guys.